In Vivado, I have a blank project for the ZYNQ device on the blackboard, and I have a constraints file that only has the pins for the first 4 LEDs. To create a block design, click on Create Block Design in the Flow Navigator. Vivado will bring up the block design view. Here you can instantiate blocks from the IP catalog, such as the clocking wizard or any other ones in the catalog, and connect them to your various modules. We want to instantiate a ZYNQ processing system block, and that'll allow us to set up how the processing system is configured when the bitstream is programmed to the device along with the FPGA configuration. IP modules instantiated in the block design can be configured by double-clicking on them. When we double-click on the ZYNQ module to configure it, we change how it is programmed at startup. The first thing we want to do is apply a preset specifically for the blackboard. That'll make sure clocking for the module and DDR timings are correct for the board. You can find the file on the Real Digital website. Apply the changes to the module configuration and go back to the block design view. Now we have an option to run block automation, and that'll add ports in the design for DDR and fixed I/O. And they represent the DDR memory connection and connections to I/O peripherals, but they're not actually through the FPGA. They're hard pins on the ZYNQ device. You'll notice that by default there's one AXI master port from the ZYNQ, and we can use that to connect to devices in the FPGA and control them from the processor. So now let's go over creating one of those modules and hooking it up. So in Vivado, select Tools, Create Package New IP, and a few options are going to be given to you. Here we want to create an AXI4 IP core. So we're going to be asked for a few parameters, give it a name, a description that's meaningful, and we're also going to be asked how many registers we want to create in the module. And that'll influence how Vivado auto-generates the module template. So let's go with 4, and we'll edit the IP, and we can package it when we're done editing it. And that'll open up another project in Vivado. Here you'll see some auto-generated code based on the parameters we gave it earlier, and there will be a wrapper instantiating another module in its own file, and that contains the actual logic for the AXI bus connections and the registers themselves. So to control the output of the LEDs, we're going to need to get them out of the module, or out of the IP core, so we're going to need to create a port on the outer module and the inner module for the LED data. In the inner module, you can see there are 4 32-bit wide flip-flops or registers, which a bunch of logic to control the AXI bus. And they're configured, the logic, to access these registers at offsets of 4 bytes. since the ARM is byte addressed, and 4 bytes is 32 bits, so each register is at a multiple of 4. So the register 0 is at address 0 based off the base address offset. We'll get back to that in a minute. So we'll use register 0, and we'll only grab the least significant 4 bits, and we'll pull those out of the IP module, which we can use to drive the LEDs, the pins for the LEDs on the FPGA. So in the file, we can just assign our LED output directly from the output of the slave register. You can also put in any other logic you want here. You can instantiate other modules if you need to control them from the processor. But for now, we're just going to drive the output port directly. Now we can review the changes made. So open the package dialog in that tab. And if you open ports and interfaces, you can see there's a 4-bit wide output that we've created, and it's picked up on. And you can also see this if you open the customization GUI. We'll see we have an AXI slave port, which was given to us by default, and we've created the output for the 4 LED values. Within the project, you can also run a simulation. You have to write your simulation code, and you can also run synthesis to make sure you don't have any errors before moving it into your block design. When you're done, in the IP packager dialog, just go to the bottom and click Package IP. Okay, so we'll go back to our original Vivado project. So in the block design, you can open up the IP catalog, and you can see that our IP has been added to it. So we can add it to our design, and we'll be given the option to run connection automation. And then Vivado will automatically hook up the interfaces of the processor and the module itself. And you'll notice it adds a couple blocks there. One of those is a reset manager, and the other is an interconnect IP. And that'll allow multiple slave modules to be connected to the same master port of the processor. So if I add another LED controller instance and automate the connection, you'll see we have 2 ports connected to the 1 port of the processor through the interconnect. We're not going to need this, so we'll get rid of that, and we'll also get rid of the extra master port. So now if you open up the address editor panel, you'll see this module's already been given an address from the tools, and that's the base address of the module, and offsets of that are what are going to give you the different registers within the module. So since register 0 is at offset 0, to access the LED register we defined, we would write just to the base address, and to read from it, similarly, read from the base address. So keep note of this address because we're going to need to use it when we write ARM code for it. So now, lastly, since we've hooked up everything else, we need to hook up the LEDs as outputs to the pins on the blackboard that go to the LEDs. So if you right-click on any connection in the block diagram, you can select Create External Connection. That'll automatically connect it to port out, and you can see in my constraints file I have everything called LED, not the LED data thing that it gave for me. So I'll just change the name to LED, and now in the block design we can click verify, and that'll tell us, if we've hooked up something wrong, or if it's detected something. Maybe we have addresses overlapping in multiple IP modules. We don't, but you can see it's gone correctly. But if I disconnect, say, the wire between the AXI port or the interconnect and the module, the tool will tell me there's an error in there, and I have to resolve that before I can synthesize it onto the hardware. So once everything's good and verified, we can right-click on the block design in the file navigator and create a wrapper for that. And when creating a wrapper, you can tell Vivado to auto-manage it, and this Vivado will take your block design, integrate your Verilog you wrote in the IP module into a wrapper to connect everything up. So you can open it up and you can see it's got all the DDR ports and fixed I/O. Those aren't actually going to be constrained to your design, but they will be connected to the ZYNQ since they are already. But you can see our LED port has been added too. Now that you have a wrapper and a constraints file, you can just generate a bit stream like anything. I'll let that go.